Hi, I'm Thaddeus Wacknamara, and until recently I was a quality control assistant at a major button cell manufacturer. And because it's been deemed unethical to undertake quality assurance testing on animals or children, coupled with my addictive personality, it quickly escalated from me eating hundreds of these little things a day to me having a crippling addiction to all sorts of electrochemical batteries. No, not today. And in the same regard as somebody who's been diagnosed with diabetes, I've had to learn to make healthier choices and give up my sugary snacks, learning to replace them with alternatives that are only moderately more inconvenient and only roughly reduce the enjoyment that I get out of life on a day-to-day basis. So let's go back some time to the caveman inventor, whom had much preferred to spend his time with his fermented berry stash rather than running around with a sharp stick or a pointed rock. He had the wonderful idea that he could instead take very large rocks very slowly and calmly and methodically up the hillside to a cliff top where he kept his berry stash, and as things that he wished to bonk passed underneath, he'd just shove one of the big bastards off, and it would tumble down upon them, bonking them very much harder than he ever could have accomplished with his hand rock. Unbeknownst to Augeas, at this moment in time, he'd changed the world. He'd invented a gravity battery that was powered by nothing but ingenuity, apathy, ethanol, and berry juice. Right up front, let's put a definition around battery. A battery is something that you can take energy, store it in it, and then, at a later time or place, take that energy and use it. But Thaddeus, I hear you say, what about capacitors with their superior ability to recharge and discharge far more often, as well as smooth ripples and or fluctuations within their input to output energy flows? And to that, I say, fuck you. Skipping forward from old mate and his rock through the vast majority of human history, we land upon a character named Galileo Galilei, another individual who very much enjoyed his fermented berry drink. One day, while musing over his life in debt, poverty, and being persecuted by the church for his beliefs in science, our old mate G.G. was pondering a rock on a rope, swinging back and forth, back and forth, back and forth. And through his deep fantasies of a swinging rock on a rope, this very smart astronomer, in very much debt and very much drunkenness, accidentally came across the concept of isochronism. Amongst other things, this phenomenon, as he'd observed it, explains that on an upswing, a pendulum will convert or store kinetic energy as potential energy, and on the reverse of that. Or the reverse of that? Instead of having our astronomer on a rope, moving back and forth, wait. Let's spin him around. No, let's just take a big metal wheel. What you can do is take your big fuck-off metal wheel and use a high-torque, low-speed chugging engine, bit of fancy gear work, and start accelerating it and spin it up. If you really work towards spinning this up to its capacity, these things are absolutely terrifying. The phenomenal amount of force that you can store in one of these by disengaging the engine and any output and just leave them spinning and spinning and spinning is absolutely fucking terrifying. I think right here we need a little bit of perspective on the energy within a flywheel. Let's take an industrial flywheel, which is about 1.5 meters wide and weighs about 1/4 of a ton. Let's accelerate that up to 10,000 RPM. What you're looking at that point in time is the destructive equivalent of somewhere in between 60 and 170 hand grenades, depending on how shitty my maths is, which Obviously left us a bit of room there. Either way, 60 hand grenades coming off of an axle and driving straight through your fucking front windows is not exactly something you're going to have a great time with. Though I don't know if my theoretical single flywheel could actually have materials to hold it together at those sorts of forces. These aren't the biggest, most complicated flywheels out there. There are huge, much more complicated flywheels which store significantly more energy and do much more harm should something go astray. Megawatts of power can be stored in the largest flywheels that we've got on Earth right now. But once again, we talk about my flywheel not surviving, and doesn't that scare you a little bit? A minor flaw in a relatively sane flywheel could lead to it catastrophically destroying itself, shooting pieces of itself away with all of that potential kinetic now energy just scattering. And I know the damage that a single angle grinder wheel can do when it shatters to some poor bastard in front of you's asshole. So the forces we were talking about tearing parts of a flywheel apart really apply due to air resistance and gravity. So let's fuck both of those off and build a really, really, really big flywheel up in space. To spin that up, what we're going to do is take a solar collector near the sun, the sort that you would use to accelerate spaceships in certain ideas that we have about how we'd get out of our solar system in the future, and we would point it at some form of collector attached to the flywheel. So now what we have is a giant asteroid-size spinning wheel of doom that is laser powered from solar energy, clean energy, and it's been spun up to the sorts of speeds and momentums and potential energies that we couldn't even imagine here in the gravity well of Earth. How do we do something with that? Look, I don't know. I didn't think this that far through. Smarter people, I'm sure, have come up with some form of like rockets to... I don't know. Forgot. Maybe we just give it a nudge out and send it. But if you consider a Dyson swarm-like arrangement of many, many solar collectors that are shooting laser beams of energy out to the various colonies, the space flywheel, if a smarter person can explain to me how you'd then actually discharge it, could be a really good way of distributing energy for all of those satellite colonies. All right, I probably got a little bit science fiction on you there, so let's back it up a little bit to castles. Castles had the, what do you call them, up and down portcullis? Portcullis? No, that's a small tool. Counterweighted, heavy-ass doors. Those were very effective at allowing people to shoot through the grates in them, and had ropes and pulley systems, rock on a rope, in order to counterweight them so that they could be lifted and dropped far more easily. One notable appearance of the portcullis in popular culture is Army of Darkness, where Ash uses one in conjunction with a chainsaw hand and his boomstick in order to protect the Necronomicon from evil Ash gaining control of it, and thereby saving the future. And while today it's fallen out of fashion to build a rock and rope counterweighted metal gate at the front of your property to protect you from the barbarians and uncultured tribes, we have its spiritual successor, the counterweighted spring-loaded garage door. The most damaging and dangerous point of ingress or egress that we have ever fitted to a modern home. 30 to 50,000 odd injuries a year are reported in the US alone. Also springs. Springs are great batteries. They spring and spring and spring until they sprung and then release all that energy. So good. As far as very heavyweight, counterweight battery machines go, there is one that has been favoured by everyone since the day that it was invented for sending your enemies dead back behind their lines, well above all others. And that is the trebuchet. It's a counterweight, a lever, and a cup. And if you put the corpses of those vanquished trying to charge your lines into the cup, preferably sliced up a little bit, you can send them very, very quickly back to whence they came. This is even more effective if you decide to add a liberal application of tar and a little bit of fire, because nothing ruins your day like your bunkmate's flaming fucking corpse landing right in front of you. Another example of a mechanical battery that doesn't use a gravity or spinning wheel approach is that you take a very large cement sphere attached to a cable, which then drives a piston, and you submerge that in deep water, ocean or a lake or similar. When you want it to come up, you pump air into it. When you want it to go down, you release the air, and it drives the piston so that you essentially have another battery. So upside down wet rocks on ropes, I guess. Australia is actually undertaking a really big project in terms of a mechanical battery at the moment in the Snowy 2.0 project. Instead of a rock on a string, all of the water from the bottom of the dam that flowed through during the day when people needed that electricity, but water doesn't stop at night. So as it keeps flowing through the off-peak times and they have an excess of energy that they require, they're using that to operate pumps to bring it all the way back up again. Then, as they require it more, they can open up the gates on those holding pools and let more water back through the dams, producing it again in peak times. This is a great way for a renewable energy to be able to have a controlled on and off peak system. So while you can't control where the wind blows or how often the sun shines, except if you're in the middle of Australia and the answer is fucking always, you can actually control how much of these giant holding pools you let out at any given moment in time. That allows us to control some of the ripples in terms of demand versus supply from various renewables. One of the actual ideas for a mechanical battery is trains. And I like trains. You take an electric train and you push it up a hill while you have off-peak or excess power in the grid, and you leave it on top of the hill. Then, when you need that power, using the train's engines as magnetos to generate electricity, you roll them back down the hill. I like trains. But Thaddeus, I hear you say, I feel like we're getting close to the end of the video, and you haven't really addressed the idea of, say, using large vats of molten salt to hold energy and then be able to boil water using that heat at a later stage. Or some form of phase-changing material that absolutely can take thermal energy and change it. Now, and that's the key point. So, I'd like to demonstrate something. Here, we have a tube. This is kinetic energy, a mechanical energy, being applied to that tube. Now, the difference between mechanical energy and some of the suggestions that you were just screaming about in my head is that you're talking about as if I were to take my heat gun here and apply it to the tube. Now, as you'll see, this isn't mechanical destruction to the tube, but what it is in fact doing is superheating my hand and applying thermal energy to the tube. there may be a later video where we talk about thermal energy and how it can be used to also become a battery. But for the time being, I just wanted to make the distinction between thermal and mechanical batteries. So, thermal, mechanical. Pretty straightforward. For the more astute of you there who noticed that I wasn't necessarily paying as much attention to the camera as I could have been during that scene, it's because halfway through filming that scene, I realised I had a jar full of flammable liquid stripping some stuff just off of camera, right next to the heat gun's position on the table and where I was sitting. I like to conclude with some sort of observation in these videos, and while we're stuck here in a gravity well, we have a lot of energy that's available to us that we can use, and it definitely goes up and down very effectively. It can even go left and right effectively if you put it on a pivot. But it's once we get outside of the gravity well, the spinning energies, or even just being able to send at something and allow that energy to be sent as a high amount of kinetic energy accelerated to phenomenal speeds, is really where mechanical batteries will come back into their own. All you need is a couple of decent sized nets and the ability to railgun out, not necessarily railgun, but accelerate something to relativistic speeds and catch it without completely fucking whatever it's hitting, to be able to accelerate something much quicker than you would be able to potentially using some of the engines out there. There's a lot of opportunity for mechanical batteries here at home, and once we get out of the gravity hellhole that we're stuck in. I'm Thaddeus McNamara, and I'm whacking odd.